last lesson for this whole unit, so it's on exponents. We're going to have fraction exponents. So we did our regular exponent laws, then we did negative exponents. Now we're going to do fraction exponents. So things that look like this. I guess I should probably highlight it. Things like that. Things like that. Hey, there we go. Working. Right. So exponents that are fractions. This one happens to be 1 divided by n, but we'll do all kinds of numbers divided by numbers. All right. To figure out what a fraction exponent actually means, we're going to mess around with a couple calculations. So we're going to start off by calculating the square root of 5 times the square root of 5. We're not going to combine it or simplify it or anything like that. We're just going to actually calculate it. So if you go the square root of 5 in your calculator, square root of 5, close the bracket, times the square root of 5, close the bracket, you end up equaling 5. Awesome. Now we're going to try 5 to the power of 1/2 times 5 to the power of 1/2. So 5 to the power of 1/2 times 5 to the power of 1/2. And you get 5. All right. That means that if root 5 times root 5 equals 5, and 5 to the power of 1/2 times 5 to the power of 1/2 equals 5, then these things must actually be the same thing. Right? That kind of makes sense. This means that 5 to the power of 1/2 equals the square root of 5. It's the same thing. All right, we're going to try it with cube roots. See if that changes things a little bit. So we're going to take the cube root of 2. I like that color. I want it up my top. We have the cube root of 2 times the cube root of 2 times the cube root of 2. If you put that in your calculator, cube root 2 times cube root 2 times cube root 2, and you hit enter, you get 2. If you put in your calculator 2 to the power of 1 divided by 3 times 2 to the power of 1 divided by 3 times 2 to the power of 1 divided by 3, you get 2. This means that these two things must be the same, right? Just like our last example. So that means that 2 to the power of 1 over 3 is actually equal to the cube root of 2. Fantastic. This idea, these two things are not coincidental, okay? But these equal each other. If you look at the first one, we have 5 to the power of 1 divided by 2 is equal to the square root of 5. What's the index on the square root of 5? Remember, index is the little tiny number in front of the root sign. It's a 2. If you look at this guy, we have 2 to the power of 1 over 3 equals the cube root of 2. So, what's the little index on this guy? It's a 3. And you'll notice that whatever's on the bottom is the same number as the index. That's because that's actually one of our math rules, and that's one of our exponent rules. Our exponent rule is that if you have a fraction exponent, you could turn it into a radical by making the bottom number the index. Right? And that'll always translate that way. Bottom number becomes the index. Miss Schaub has a cool song. Some people had Miss Schaub last semester for a different class. Did you guys do this stuff last semester? Did you do fraction exponents? Yeah? Do you remember what her song was? Yeah? I don't remember it. It's like, the index goes to the bottom because the bottom is the index. Is that it? Yeah? All right. That's not bad that I remembered it. So I usually bring her in and do a little song. And she just sings a song, and I always forget how it actually goes. And she has a dance, I think, with it, too. I don't have to dance. So the song is, the bottom is the index because the index is the bottom. The bottom is the index because the index is the... Yeah, bottom. You killed it. You guys should go to concerts. Yeah, you wouldn't do very well there. That's the rule, okay? That's our math rule. So we're going to slide down a little bit and do a couple examples so you can see how it actually works. It says to write it as or evaluate it. We're not going to evaluate it. We're not going to verify it. We're just going to convert it to a radical. So write the following in radical form. That's what we're going to do. We have 25 to the power of 1 divided by 2. I know that fraction exponents change to become radicals. The bottom number, this guy right here, becomes my index. The rest of the question, the 25 to the power of 1, stays underneath and becomes your radicand. Bottom becomes the index. Everything else becomes the radicand. Now, we wouldn't write it like that. I'm very much explicitly showing that the 2 and the 1 go there. My final answer would look much more like this. Square root of 25, right? I don't need to write the 2, I don't need to write the 1, because they're usually invisible. We don't usually write to the power of 1. We don't usually write the 2 for square root. We just know it's a square root. Awesome, let's try this one. So we have 64 to the power of 1 over 3. The goal is to change it to radical form. So I know I need to have a radical. That's what fractions tell me anyway. Fraction exponents mean it's going to be a radical. The bottom number of the fraction, this little guy here, becomes the index. The rest of the fraction, or sorry, the rest of the power stays underneath. And I'm going to keep putting to the power 1 just so you see where it goes. You wouldn't need to write that. Last one, same idea. We have 81 to the power 1 over 4. We know it's going to become a root. The bottom number of the fraction becomes the index. The rest of the power becomes the radicand. Awesome. Go ahead and try the next 4. So see if we can convert them into radical form. I'll give you a minute. I have x to the power of 1 over 2. I need to convert it into radical form. Plus, I just know that fraction exponents change into radical form. And I also just know that. Radical looks like this, with a radical sign. The bottom number is your index, so there'd be a little 2 for my index. And the rest of the power, x to the power of 1, stays as the radicand. You don't have to write the 2 and the 1, and you'd have the right answer still. Awesome. Next one. Same idea. I have b to the power of 1 divided by 3. I need a radical form, so I write my radical sign. The index, the little number that goes here in front of the radical sign, is the bottom number, so it's a 3. And then the b to the power of 1 is the rest. For 3, change it to a radical form. I do my radical sign. The bottom number of the fraction is the index. The rest of the power goes underneath. And the last one's a little trickier. So they used letters now. They had n as the bottom number and a. Well, I guess we've always had a as the base, letter as the base. When you have a number on the bottom, little n right there, nothing changes. You're going to treat it the exact same. So the index, instead of being a number, is an n. And then a to the power of 1 stays underneath. So even if they throw something crazy at you, like letters, you can still handle it the exact same way. The bottom thing of the fraction goes to the index, even if it's a letter. Awesome. We're going to skip that part a little bit, and we're going to go down to this part C. So right at the bottom of page 93, we have some examples. These ones are a little different than the other ones we had because the bottom number has always been changing, but in all previous examples, the numerator, or the top number of the fraction, was always 1. Now we're going to have something different. So the top number, you'll notice, isn't 1 anymore. They're changing it up. When we go to convert things, and it's not a 1, we treat it the exact same. So when we go to put this into radical form, we draw a radical sign. The bottom number becomes the index. and the rest of the power, which is x to the power of 5, becomes the radicand. Like that. Bottom becomes the index, everything else the radicand. We'll keep it going. So if we have b to the power of 4 divided by 5, we change it to a radical. The bottom number becomes the index. The rest of the power becomes the radicand. Awesome. Do the last two on your own, and I'll put the answer up on the board. Fantastic. So I put the last two up there. We have the square root of p to the power of 5. You see I've tried to color code it somewhat. So the bottom number is red. You'll notice the red number is the index. Bottom becomes the index. The rest of the power becomes the radicand. Same thing for the last example. The index is n because the bottom number was n. And then a to the power m becomes the radicand. What's underneath the root sign? Awesome. All right. Other ways to write this stuff. We're going to skip down to part C on warm-up 3. We have 64 to the power of 3 divided by 2. So on part C for warm-up 3. Should be top of page 94, 95. 97, 94. Hey, it's off page 94. Warm up 3, part C. Awesome. We can convert these the same way. Okay, so I'm going to convert them quickly, and then I'm going to show you a different way we can write them. So this one would become square root 64 to the power of 3. This one would become square root 4 to the power of 5. And this one would become 4th root 81 to the power of 3. That's how all those would convert to radical form. Now, there's technically another way that we could do this. Right? And the other way we could do it is we could take this exponent on the radicand and write it outside of the radical sign. And so you could change this to look like this. Still square root 64. But the exponent 3 is out here. It works better if we put some brackets around there to really show that the cube is on the outside. So remember how we've said before that you would just bring the exponent in, right? You'd bring that 3 into the brackets. The root sign basically works as brackets. So I could bring this 3 into the 64 and it would look like I originally had it. Or I could go backwards and I could put the 3 on the outside. Sometimes you'll see things written this way, the new way that I just wrote it up here, this way. Most of the time, you'll see it the way we've been doing it, but I want you to just have exposure to it, so if it ever happens, you're not like mind-boggled by it. So this guy right here, that means it would convert to be the square root of 4, and the exponent 5 comes out top. The next one would be the 4th root of 81, where the 3 comes out. And those are the exact same things, the exact same one. Fantastic. Warm up number 4. We're going to just try to simplify this guy. Maybe this one. We're going to write this thing in radical form and with a positive exponent, because we learned yesterday that you're not allowed to have negative exponents anymore, right? Perfect. Yesterday, when we did negative exponents, we said you do all your exponent laws first. So all your adding, subtracting, power of a power, you do all that stuff first. Then you deal with negative exponent. Now, after you do the negative exponent, you'll deal with the fraction exponent. Okay, so that's the order in which you're going to do things. All the addition, subtraction stuff you can, deal with the negative, deal with the fraction. We learned yesterday that if you have a power that has a negative exponent, like this guy right here, that we pretend that that thing is a fraction. You don't have to pretend, it really is a fraction. Everything in the world is divided by 1, we just never talk about it. Okay, so we have a power divided by 1. When you have a negative exponent, we can change it to a positive exponent by taking the entire power, one of the different, and moving it to the other side of the fraction. So in our case, we would be taking 8 to the power of negative 2 over 3, and we would now move it to the bottom of the fraction next to the 1. I would be left with nothing on top, which is a 1 on top, divided by 8 to the power of 2 divided by 3. And you notice that the exponent is now positive. So when you move the power from one side of the fraction to the other side of the fraction, it creates a positive exponent. That's just a review on yesterday on how to deal with negative exponents. Take the entire power, move it to the bottom, make it a positive exponent. Wonderful. Now we have to convert this thing from fraction exponent to radical. To do that, the top would still be 1. On the bottom, it becomes a radical sign, so it looks like this. The bottom number of the fraction in the exponent becomes the index, so we have a 3 right there now, like this. And the rest of the power is now your radicand. That's how you would deal with negative fraction exponents. You move everything to the bottom, then you change it to a radical on the bottom. Notice that it's still 1 divided by. Awesome. Your radical laws, or your radical exponent law, rational exponent law, your fraction exponent law, looks like this. This is like the technical way of showing it, like the actual formula. They could also write it like this. The difference being the first one has the exponent outside the brackets, the second one has the exponent inside on the radicand. But it's the same thing. The next rule we just learned is right here with the negative exponent. It says the negative moves the power to the bottom, and then it changes. This one's the same thing. Negative goes to the bottom, and then it changes it to radical. Awesome. Before I let you all run off into the world, you guys can try these questions right here. So go ahead, give it a shot. Don't worry about the calculating it. Don't worry about verifying a calculator. Don't worry about evaluating without using a calculator. I just want you to convert these things. I'll give you a chance to do these 7 questions, and I'll do them with you. The goal is to convert all these to radical form. That means the bottom number of the fraction exponent becomes the index. This becomes square root of 25 to the power of 3. Bottom number index, everything else becomes radical. This one would become the cube root of 1,000 to the power of 4. Bottom number becomes the index, everything else becomes the radicand. We'll keep going with that. We have a negative one this time, so I need to change this entire power and put it under a fraction. That makes my exponent positive. Okay, that's the first step. Make the exponent positive. Second step, now change the bottom to a radical symbol. So it becomes the cube root of 27 squared. Now, I've taught this course like a gajillion times. When we have questions like this, people do the first step, and they do the second step, and they forget to write the 1 divided by. Does that make sense? And they just write that part right there, the bottom part. you need to still write 1 divided by cube root 27 squared. Right? Make sure you're still writing the 1 divided by. Don't just lose the fraction. You need to be on the bottom of the fraction. Awesome. Last one, we have a negative exponent, so the entire power has to go under a fraction. It changes my exponent to become positive. Now I can change the bottom to become a radical, 4 through 16 cubed. Awesome. E. If I'm looking at that guy, I don't have a negative exponent. I have a negative base. Negative bases are okay. That's all right with us. So we just need to convert this into radical form. The bottom number becomes the index. The base is still -8 because it was in brackets. And then squared. Now, it would be a good idea on most of these questions to maybe simplify this if it's possible. So, like, for instance, that radicand, instead of being written as -8 squared, you could write it as, you could write it as 64. So if you actually calculated that, it would change to be 64. Awesome. F. F's a little bit of a tricky one. The reason F is tricky is because it's the exact same as E, but without brackets. And what the brackets are doing is it's telling us that the negative is also part of the base. The negative is a part of this exponent. When there are no brackets, they're saying that the negative is actually outside the base, meaning it's not a part of the radical. It's out front, like that. Right, so minor difference, significant difference in the answer. This one, the negative came inside with the base. The negative got squared with the base. This one, the negative is not a part of the base. Negative stays outside of the root sign. Awesome. Last one, probably the hardest one. We have, you're not going to get a question like this, okay? Just for the record, you're not going to get one like that, so don't stress about it. But how you probably should do it. You should evaluate what's in here. Meaning you should simplify that. So if you put that in your calculator, 3 squared is 9, plus 4 squared, which is 16. You should end up getting on the inside of that thing 25. And then 1 over 2. Like that. Then you can convert that thing to become radical form. Radical form would be the square root of 20. You won't get a question like that, so I wouldn't stress that one if it was stressing you out. Awesome. Try these two. Give it a shot. See what happens. It's a hard one, but try it. Remember that you need to bring the exponent in. That's my piece of advice. Okay, so that's going to be your first step. And then see if you can get it all the way to become radical form. I would start by bringing this exponent in. Okay, that's my power of a power law. So I have an exponent on the outside of the brackets. I should bring it inside the brackets. And that would change my question to become 9 to the power of 3 over 2 divided by 4 to the power of 3 over 2. Awesome. From there, I now have fraction exponents, top and bottom. Both of those need to be converted into radicals. And I treat them kind of separately. So the top one is going to become its own radical. It'll be the square root of 9 cubed. And the bottom one is going to become its own radical. It'll be the square root of 4 cubed. Like that. And that would be good enough for a final answer. If you calculated it further and figured out what 9 cubed is and what 4 cubed is, that's fine. But this would be sufficient for me. Awesome. Next one. I'm going to do the same thing. I'm going to distribute this in. It's slightly different this time because I have 9 to the negative 3 over 2. And I have 4 to the negative 3 over 2. My attempt to not let the 4 connect on the top was to make a really wide 4, and now it just looks really weird. Awesome. The next thing I do, because I've dealt with my power of a power rule, is I have negative exponents. I need to deal with these negative exponents. This is a negative power. It needs to go to the other side of the fraction. This one, also a negative power. So it needs to switch to the other side of the fraction. That means I now have 4 to the power of positive 3 divided by 2. Divide by 9 to the positive 3 over 2. Like that. So power of power rule, deal with the negatives, flips your powers that are negative. Now you convert. So on the top, I would end up with the square root of 4 cubed. And on the bottom, I'd end up with the square root of 9 cubed. And that would be sufficient pylons. Awesome. You have the rest of today to work on the practice questions.